Video 2 on differential equations, and in this one we're going to introduce the separation of variables method as I outlined in the first video, and in particular we're looking at what I call type 2 in my little system, and it's when dy dx equals some function of y. If you haven't caught the first video, it was the type 1 and a general overview, and it was solving differential equations when we have a function of x, which is not really anything too new, and but this is new, type 2. So the rate of change is proportional to the actual value of the function, is another way of saying that. So if we had to solve dy dx plus 4y equals 0, and we're given some extra information, which means we can find a particular solution from the previous video, you remember that? And the particular solution is still an equation, alright? When you solve a dE, you get an equation. You might be thinking, I can rearrange that. Dy dx equals negative 4y. Yeah. Then you realize what's new about this. Okay, there's not an expression involving x on the right side, it's negative 4y. So this is where we have this separation of variables. We can't use our regular approach. So the separation of variables, separation of variables, and that's essentially axiomatic, okay? We're not going to get into the proof end of things, but basically, or the philosophy, but basically it means we can separate dy dx, so the differentials can be separated and pasted on the other side of the equal sign to each other. So what I like to do is to rearrange this, and it can be rearranged as dy equals negative, I just put the negative out there, I don't like putting on the denominator, okay, so dy over 4y, with the negative sitting out the front, equals dx. Now dx is essentially 1 dx, okay? What some people do is they don't do that, they just invert on this line up here, they invert both sides, and you would get that there, negative 1 over 4y, and you would then rearrange, and you'd get negative dy over 4y, and you can see that's the same thing. Okay, so that's a mild variation, it's not a big difference there. Okay, so you might see that in some books or whatever. No biggie, it's pretty much the same thing. Now, the axiomatic part is that we can integrate both sides, so I guess I jumped the gun there. I like axioms. And we can integrate both sides. I want to get that constant there outside, but that's nicer. So it's negative a quarter outside of the integral of dy over y, and integrate the other side with regards to dx. You can do that. And just remember, when I'm writing things like dy over y, I'm writing 1 over y dy. Okay, so it's really, we're integrating 1 over y. Okay, dy, you could write it like that, but I'm writing it with the dy on the numerator. And we know that that will be negative a quarter natural log of the absolute value of y, and that is x plus c. So to get the solution to this, I want to make y the subject. Okay, so that should make sense to you. Y needs to be rearranged so that it's the subject. Okay, because that's the solution, is an equation involving y and x if we're solving something that initially involves dy dx. So we can multiply the right hand side by negative 4 to do that. Okay, so we've got negative 4 outside of x plus c on the right side, and we've got log y on the left side, and negative 4x take 4c, and we've got, now because negative 4c is just some constant anywho, use some reasonably smart choice of unused symbol for reasons, stop and think about it. Capital B would be a good one, okay? I don't think B will pop up again in this problem, so I'm going to use B. And that means that log y is negative, or B, take 4x if you like, because I've said negative 4c is B, right? So you could rearrange that, and let's take 4x. Now I'm going to write both sides in exponential form using what you know about logarithms. That's by the way, in exponential form, both sides there. So that would be y equals e to the b minus 4x. And look, we have a third constant, e to the b. That's just a constant, so let e to the b equal some other unused letter, capital A. Alright, so what we have is, before we get to that, we have an exponential there, that index law. So remember x to the a minus b, or more usefully, we could have it as x of a plus b is when we have x to the power a times x to the b. You can turn that into a plus, alright? It's plusing a negative. So that is doable there. It's actually more convenient than using index law 2, where we have the division going on, okay? So I don't want to turn anything into fractions. So I've chosen index law 1, okay, where we've got this as a negative 4x there. So it's like me saying, back on this line here, we've got e to the b plus negative 4x, okay? So, alright, so there we go. That's where I'm going to make this substitution. So we have a, so it's a nice neat exponential equation there. So we have a e to the negative 4x on the right hand side. So when we have y of 0, we have 3. So when x is 0, y is 3. So 3 equals a. This is how we find what a is, you see. And we have e to the 0, which is 1, so a equals 3. Okay, so in the final line, we can drop the magnitude absolute value thing, and we've got the solution. So y equals 3e to the negative 4x is the solution to that differential equation.